Hello. Is this working? Can everybody hear me? This is the first time I'm using the this platform. So, all right. Thank you for having me here. I'm Valentine, and I will present today about why security professionals should write code. But the title is a little bit misleading, and I'll tell you why in a second. You can put up the slides. Yes. Oh, this is not really a nice view, but we'll go like this. I think this is better. Yes. All right. So, thank you for having me here. My name is Valentine Mairet, and I'm calling in from the Netherlands. So it's a little bit dark and cold here. This is why I'm just like this, and I'm a little bit sick. So I apologize if my voice goes a bit up and down, but it's all good. Thank you for being here and listening to this. I hope I can entertain you tonight for me, today for you. Who am I? I'm Valentine. I'm originally French. I live in the Netherlands. I have a background in red teaming. Then I moved to blue teaming, and now I like to call myself a little purple, let's say. So, doing red teaming operations in together. I mean, to working together with a red team to fix security issues from the incident response team at GitLab. I used to work for McAfee as a threat analyst. I was at KPN before. So KPN is the Dutch telecom company, the largest Dutch telecom company, where I was a red teamer. And I have some background in security operations at Adyen and Fox IT. I love doing conferences. I've spoken at a few conferences in Europe, never in the States. So it's kind of nice to be in let's say, I mean, this is an online conference, but this is hosted by United States people. So it's also nice to be here. I studied computer science in the Netherlands. I'm the founder of WICA, which is the Women in Cybersecurity community of the Netherlands. This is our website. We do a lot of meetups. We meet monthly to discuss everything cybersecurity, not only technical, but also strategic, management, governance, cybercrime, everything you can think of that relates to cybersecurity. We've actually, during the pandemic, we moved to online meetups, and we're still doing sort of a mix of both. So if you're ever interested, you can always join. The website will take you where you need to be. But my true passion is actually writing fantasy and playing Dungeons and Dragons, which has nothing to do with cybersecurity, but I still love my job anyway. But this is my true passion. And recently, actually, about Wicca, this is so the Koninklijke Bibliotheek is this royal library. It's called. It's this archive initiative from the Ministry of Culture here, and they decided to archive our website because they thought it was good for society and for Dutch society, and they saw it as valuable for history of the Netherlands. So we were quite honored to have been archived by them. So that's really nice. By the way, if there are any questions, I don't see the screen, so I'm just going to like move this here so I can see if there are questions. Okay. So why security professionals should write code? Like I mentioned, the title is a little bit misleading. So the actual title here would be why security professionals should contribute to building secure software. And you don't have to really write code, but it's nice if you understand a little bit about what it means to build secure software. And this is what I will tell you today. So in the this is a meme I find so perfect to illustrate a bit of some pentester attitude that I've had and that many friends of mine have. Is when you find a bug, you feel super good about it. Of course, like you've tested an application and you found that a way to break it, and you're like, yeah, we're rock stars. And when I moved to the blue team, we had the other sort of attitude when there was a bug that was found by the red team, and we saw the developers as those little pandas that were trying to build a playground or play on the playground. And we found out that their application, their playground, was actually not as secure as we had hoped. And we're like, our devs are building again. It's bad, and I know this is not the attitude to have, but it's something that I've noticed in my career in both red and blue, is that we had this sort of back and forth kind of criticizing developers and saying they build bad software and we're awesome for breaking it. So this is something that that we should move away from by contributing to contribute to building secure software. But how do we exactly do that, and why? This is what's coming next. So if you don't have any experience coding, I'm just going to explain to you a little bit about how everything fits together in this piece of code. So if you know the command ping on your computer, which is basically just saying trying to find out if a machine is online. I wrote a little Python script that basically just calls this ping command on whatever IP you give it. So you run it, you give it an IP address, it takes the command and runs ping on it. So I'm going to try to demo the script. So I can do this. Yes, should be like this. So this is the script in Python. You don't have to worry about all the wrappers around it. But the only thing you have to worry about is this. This function says I'm going to take the IP the user gives me, and I'm going to run ping on it. So ping normally works like this. So you can ping Google 888. That's Google. Okay, so you say, oh, I'm sending bytes and I'm getting something back. Oh, Google is up. That's great. We can still Google. So if I run the wrapper around it, this is spoilers, but it's gonna ping 3 times and then it's gonna say this. So imagine the software runs on an application, on a website, for example. You build a nice website that pings other machines. Great. And this is the code that you use to do the functionality on this website. But because you just take the input of a user, and when we're pen testers, what we look for is these types of situation where we're taking input from the user and just putting it in a command like this. And because we're giving this so much freedom to the user to decide the input, the user can actually put malicious input. And in this case, one way to sort of escape the ping command is to tell it to break. So when you writing bash to break the command, you do a semicolon or something else, and then you want to get some secrets, or you want to fetch some secret data, or you want to reboot the machine. Maybe you want to do some evil stuff, and this is one typical command that hackers will execute, or hackers or pentester will try to execute to see if they can access this file, etc passwd. You don't have to know what it is. It just contains some secret stuff. So we try to run this, and then we get access to this file. So I will bring back the presentation. So if we have this software running and we notice that we can actually break the ping command with a semicolon, maybe you want to try to break it. And maybe you want to try to remove that semicolon from whatever input you have. So this is, for example, you've been hacked. You know, oh, our application is vulnerable to this evil character. Let's tell our developers, and the developers, they think, okay, this character is bad, so we're just going to remove it from any input we get. But there's another way to break it than the semicolon, because there are dozens of characters that can be used to break the application even more. And one of them is the pipe symbol, which is this one. So the next time you got hacked, you told your developers, oh, the pipe symbol is also bad. So then they added another check for the pipe symbol, and they say, okay, we're just going to remove any pipe symbol. But there's another one, which is also a very bad character, and that's the ampersand. And the ampersand also allows you to break the application again. So the developers got notification of this, and now they're fixing this as well. By just doing, we're gonna remove every bad character that we get in the input, and we're gonna it's going to be some code that looks like this. But if the security if the security professionals that talked to the developers in the beginning, like, and actually looked at the problem instead of trying to fix the little symptoms, they might have figured out how to do this right. And that's a general rule in building secure software, is if there's one entry point, hackers will find a way. And in this case, if you just sanitize, that's the input sanitization story. If you just say, okay, we don't, everything that has a semicolon, we remove it, then they'll find the pipe symbol. Everything that has a semicolon and a pipe symbol, we remove it, they'll find the ampersand. So that it's always going to be like this. So the right way to do it, and I'm not going to get too much into detail with this, but it's just saying I'm only accepting what looks like an IP address. So if the developers and the security professionals had sat down together and said, what are we actually doing with this application? Yeah, we're trying to ping IP addresses, and maybe we should just, accept only everything that looks like an IP address and nothing else. And this is actually the right way to do it, but this is just an example of how you would actually do this. There are multiple ways to do this as well. You don't necessarily just need the this is just matching against the regular expression of an IP address. You can also do other things, but this is a secure way of doing it. So building secure software is challenging, especially if you keep going back and forth with, our application broke, let's talk to the developers, then they fix the symptom, up it breaks again, talk to developers, you fix the symptom again, but you're not actually fixing the internal issue. Is that the developers, they didn't think about, oh yeah, we're only accepting IP addresses, so let's just accept that and nothing else. So but those developers, they also have a lot of work to do. So this is, for example, this is actually GitLab, the GitLab on GitLab, the GitLab source code from GitLab. And developers have so many other things they need to think about. And one example of this is on this open source software, there are 40,113 issues open, meaning that they have 40,000 plus problems they need to fix in general, which is quite a lot, to be honest. And when you look deeper at those issues, you want to find those that actually mention security. So they are probably security-related issues. You find 6,000 security-related issues. So developers, they might have other problems first, because from the 40,000 issues, there's already 6,000 issues related to security that are open. Maybe they want to try to fix that instead of constantly being pushed by the security teams to fix other things. So we're going to go down the process of actually building software. So if you have a cool website that you want to build with a lot of users, and because this cool website might handle user data, you want to secure it. So you've done that. But the user data is stored in a cool database, so you secure that database as well. And then you need to secure the communication between the cool website and the cool database. And then if your cool website and your cool database, they all run on a server, on a certain infrastructure, or in a container on a server, or some virtual machine on a machine, or anything else, then you want to secure that as well. Because we've heard of websites being hacked through other means than just hacking directly the website, but maybe they hacked into the server that was hosting the website, and then the website or the database is down, and then everybody has access to the user data. So you need to secure the server as well. Now, if your website and your database on your secure server communicate with other websites, then you need to secure that communication as well. And websites that communicate with other websites, that could be some cloud infrastructure, it could be anything like software as a service infrastructure, or anything else. So you need to make sure that this is also secure. And this is fine for now. Developers, they've done a great job. They've managed to secure this. But now imagine all these other websites are sort of communicating with a ton of other machines. And this is something that you find in a lot of different infrastructure. Like I mentioned, cloud architectures are like this. A lot of different components are communicating with each other. So you need to secure that, and you need to secure those communications with the other machines, and you need to secure everything. This is fine. We're not under pressure. Oh yeah, and of course, add on top of this that there are deadlines, there are users that are waiting for their updates, or yeah, you're under pressure for management to complete this project. So you're working on that. But what if you forgot one component? You forgot to put a secure password on it. For example, you left it at I don't know, something 123. Then this breaks. All the effort you put into securing everything, one component was not secured. You forgot that one, and now all the effort you made is just was not useless, of course, because you built that really nice project, but it broke. So that hacker is going to be like, hey, you missed this one right here. We're rock stars. And because you because you didn't secure it properly, the database gets accessed and top secret documents get leaked, for example. And you will find in hacks that have happened in history. And recently you might have heard about the SolarWinds attack, where it was not directly the companies that were affected. The vulnerability did not come from software from them. It came from the SolarWinds software that had somewhere there was a bad password. People managed to access the software, and they managed to roll out a malicious update to all the SolarWinds customers, and then everybody got hacked that way because of that one password that was weak. So you can see how it can get really, really wrong. So as a developer, we go back to the pressure, because you need to make those 21 different locks. You need to secure 21 different things, and sometimes it's even 99 different things. You need to think of all the ways that it could possibly go wrong, all the ways to pawn the application. You need to make the application, you need to maintain it, and you need to bear with an impatient client, manager, deadlines, and you're under a lot of pressure. And as a hacker, pentester, or just even like a real malicious actor, you just need to break the application, like this cat is doing right now. I really like this picture, that's why. So why should security professionals write code? Why should they care about building secure software and actually empathize with developers? Compassion, because now they can understand how hard it is. So I'm not saying that you yourself need to write code on your daily basis, but it's all about understanding and having compassion for those poor developers that are under so much pressure to build a secure application, while we as security professionals, we just have to find one way to break it, and then we're happy, we're rock stars. And same for blue teamers. We need to stop seeing developers as those pandas who don't know anything, but we need to actually practice a little bit of compassion towards them. And that boils down to teaching a person to fish and go fish together, because how do you practice compassion? How do you actually work with those developers in a good way? You train them to recognize security problems, have discussions, especially with that ping example. You could have discussed exactly, what are we exactly doing here? We're testing an IP, we're pinging an IP address. Why do we need to accept all the characters? Let's just accept IP addresses and nothing else. So we don't have to worry about malicious input anymore. But you share knowledge with the developers, because when you're in a threat research team or anything, you're like on the front of everything that's happening in the cybersecurity world. So you can also share that knowledge that you get with the developers, the most recent vulnerabilities. You can tell them the biggest hacks that you found out for example, the SolarWinds, and try to see in your organization if there's no such case that is similar to that, and work with them towards fixing it. Code reviews. Developers do code reviews to see if all the functionalities are, or if the code is well implemented and the code is nice to read. But you can also participate as a security professional doing code reviews to identify security issues within the code. Work with the developers to configure stuff, so to configure the entire infrastructure, and join the development sprints in a DevSecOps operation. And DevSecOps is a very nice marketing term, but it's actually a good thing to do. And one of the first initial sources to go to is the OWASP repository, which is a open web application security project, and they have a ton of resources on how to actually do software security knowledge, share it into the software security, into the software development lifecycle, and how you can actually contribute to development lifecycle as a security professional, and not necessarily with coding knowledge, but just the knowledge of what's happening in the security world can also help. So this was my presentation. Thank you very much. If there are questions, I gladly hear them. If you want to reach out, this is my Twitter handle, and I think I'm on time.